Hello, everybody. Welcome to the talk. First, let me introduce myself. I'm a lecturer from NUS School of Computing. I'm mainly teaching artificial intelligence and data science courses. I'm very happy today to deliver this talk to all of you. As Emily mentioned just now, you probably cannot voice out your opinion because it is a webinar session, but do feel free to leave your comments or questions in the Q&A box. Towards the end of the webinar, I will address them. Yeah. Okay. I think we probably can start. So this is the agenda for today. So first, I will give you a very quick introduction on what is AI, artificial intelligence. And after that, I will give you a live demo on a cutting-edge AI technology called deep learning. And following that, I will provide you some AI case study, mainly utilizing deep learning technology. Then towards the end, I will summarize with a focus on AI and the data. Okay, so what is artificial intelligence? Artificial intelligence is nowadays a very popular terminology. Everybody is talking about it. So the definition of AI is very simple. It is so-called the effort to automate intellectual tasks normally performed by humans. And so the idea is very simple. Basically, we want the machine to do something that only human can do. So that is the definition of AI. AI is actually a very, very general field. It covers many interesting topics, which including machine learning and deep learning. It also covers many other technologies or approaches which do not involve any learning at all. So let's start with some history. AI started actually long time ago, around 1950s. So in the early stage, AI technology focused on symbolic AI. And so this is what we call rule-based program. So basically people utilizing data and rules, and we need to set up the exact rules by ourselves to let the computer do something previously only human can do. And at this time, the famous application is expert system. So at this stage, AI technology focusing on developing many expert systems in different industry, different applications. Like you may not hear about expert system, but I do think you have the experience calling your favorite bank. And then they will ask you to press 1 for something, press 2 for something, right? Sometimes that can be quite annoying. So behind this telephone system, there is this is a typical expert system. And so they set up very specific rules. If you press 1, they will direct you to certain function. If you press 2, they will direct you to another set of function. So all those rules are hard-coded, and it is designed purely based on the bank's functions, structures, and some experts give some advice, and people develop such expert system to handle some telephone calls, basically to let the machine do something. And so they don't need human being to be there 24/7 answering a phone call. So that's a very simple example of the expert system. Expert system is also very useful in the medical diagnosis. So you don't need to read through all the diagram. I'm just showing it. So this is a diagram. Basically, people develop to develop an expert system on diagnose diabetes. Okay, so you can see, so there are many different rules to diagnose whether a patient has a diabetes. You need to check the the patient's situation, age, some symptoms, some factors, and some test result. And so all those details are hard-coded. Okay, they cannot be changed, and they are designed by some computer expert and domain expert, especially the medical expert who are who are specialized on the diabetes. Okay, so all those things are hard-coded. Yeah, I just want to emphasize this again. So that is the focus of the symbolic AI stage. When people develop those expert systems, they have hard-coded rules, and they need a lot of knowledge input from the expert to develop those systems. Okay. And then very quickly, I think you can see the problem with symbolic AI, right? Because all the rules are hard-coded, and you need a lot of expert advice, and you develop expert systems to diagnose diabetes. Then later you want to develop another system to diagnose heart disease. Then you need another set of system. You need to do all the work from the starting point again. Then you need a lot of heart disease expert to tell you what are the rules, then you design them. So this is apparently not very scalable and not very efficient. Okay, so because of that, we move to the machine learning stage. So machine learning algorithm being provided like I think earlier before this decade, but since 1990s, that is the time machine learning algorithm being actually applied in the real industry applications. So what is machine learning? Instead of design the rules and everything, machine learning basically is using some algorithm to learn the rules. Okay, so the rules are not hard-coded. The rules are learned from data and some labels or target. Okay, so we need some data. So this is an example of how to diagnose diabetes. So we get some data from some hospital. Then they give us some records of different patients. So each row here is a patient. And their features, like certain features they think which are used to diagnose whether this patient has diabetes or not, like glucose, blood pressure, age, and some other medical terms. And they also give us an answer or a label, which is telling us whether this person has a diabetes or not. Okay, so we use this data, then we feed this data into the machine learning model. Then we can train a machine learning model. And this machine learning model basically is a set of rules which automatically tell us whether this patient has a diabetes or not, based on all those input features. So there are many different kinds of machine learning models. So here I show you a simple example. So this is a decision tree model. And so by feeding all this data into a decision tree model, and after you train a decision tree model, so this is what you get. So you will learn a decision tree model, and this model will help you to diagnose whether the patient has diabetes or not. So if you quickly look at this decision tree model, first they will check patient's glucose. And then if it is smaller than 123, it go to this branch, otherwise go to another branch. Okay, then otherwise, after that, they will check the BMI. And after that, they check glucose again. And if it is still very high, then if you end up at the red color nodes, and that means it's highly likely you have a diabetes. If you end up at the blue color nodes, okay, or the light blue color nodes, then it's likely you don't have a diabetes. Okay, so that's how the machine learning work. What we want to emphasize here is you learn the rules. Okay, so all those rules are not hard coded. Okay, it's learned. Okay, it's learned from the data here. So if you feed in another set of data, okay, into the machine learning model, they may learn some other rules. Okay, if you add in more data, they may update the model accordingly. Okay, so and another thing is this machine learning approach can be generalized very easily. So if you want to build a machine learning model to diagnose heart disease, okay, then you just collect another data set with all the indicators for heart disease and the labels, whether the patient has heart disease or not. Then feed those data into machine learning model, and then the model will be able to learn a set of rules to diagnose heart disease as well. So that's the biggest difference between symbolic AI and machine learning. Machine learning learn all the rules through data. But at symbolic AI stage, all the rules needs to be set by the experts. So there is a question, say, what kind of software do you use for machine learning? Yeah, that's a good question. There are actually many available software. So for in the academic area, I think most of people using Python. Python has many open source package available to do machine learning, deep learning, etc. But for business user, I think there are also some like graphic interface machine learning platform like RabbitMiner or some other software. They allow you. You don't need to actually. You don't need to do any coding. You just do drag and drop. You can build a machine learning model, then load data, then train the model. Okay. Oh yeah, I think maybe you asked for this for this decision tree model. For this one, I actually use Orange. Orange, if you Google Orange data mining, you will be able to see that. It's also a graphic interface software. I just feed in those data into I need to build a model, but the model is like a drag and drop. I can connect different applications. Then they will just visualize the model, then you can do it easily. Okay, so for this specific figures here, graphs here, I use Orange, yeah, to create. Yes, yeah, some comments. See, symbolic AI is where we put rules in. Yeah, you can see that. So it's like for same problem, we want to diagnose diabetes patient, right? So we need to handcraft those rules. So all those rules are not generated by machine. It's like you survey some diabetes expert, and they will tell you this is normally how we do to diagnose whether a patient has diabetes or not. So you record everything logically, okay, very logically, step by step, and then you code it into, you hard code this rule in the computer. Then you can use this expert machine. Next time you use this, first they will ask you what's the patient's situation, then you need to enter all this information. Then they will ask you patient's age and all the things. After you finish enter everything, then they will come out a diagnosis. Okay, and so that's the early stage of AI. It's hard-coded rules. You can see the the advantage is there is a lot of transparency. You know exactly how the machine is making decision. But the disadvantage is also very obvious. If something changes, you need to update the whole system. Yeah, but for the machine learning stage nowadays, we don't do that anymore. We just feed the data into the system. Then we will use the data to train a model. So this time I train a decision tree model. Then you still can clearly see how the model makes decisions. But if I train a neural network model, you may not understand how the model makes decision. You will just know the final decision from the model. Yeah. So there is some pros and cons with a machine learning model. The biggest disadvantage is for certain models, like the neural network model. It's like a black box. You cannot tell. There is very few transparency. You actually, most of the time, you don't know how the model is making decision. Decision tree model is actually a very transparent model, yeah. But the advantage is also very obvious. Nowadays, the machine learning model can make decision, make prediction very accurately, yeah, compared to the traditional rule-based system. Oh, there's another question. How much data is required to build a good model? How to test the reliability of the model? Okay, let me answer the last question first. So normally when we build a machine learning model, we will not use all the data. Okay, so actually assume this are all the data we have. We will only use like 80% of data to train the model. Then we reserve, let's say, 20% of data. This is what we call testing data. Okay, we will hide those data from the model. We only use the training data to train the model. Then after that, we will use testing data to test the model performance. Then we roughly know how good or how bad the model performs. For the first question, how many data? That is generally, if your data is good quality and relevant data, okay, the more the better. But data collection is a very expensive activity, right? So it depends. It depends on your problem. If your problem is very complex, if let's say down here I have around 1, 2, 3, 4, 5, 6, 7, 8 features. Okay, based on these 8 features, I'm trying to predict whether a patient has diabetes or not. But if your data has like 800 features, then you probably will need more data records. So it depends on the number of features you have. It depends on the complexity of the problem. The more complex your problem is, you will need to build a more complex model, and at the same time, you will need more data. Yeah. Oh yeah, that's train test split. Yeah. Okay. Maybe I need to move on. So that's machine learning. So machine learning already create a lot of revolution in the AI industry. A lot of company actually earning a lot of money by utilizing machine learning algorithm. So if you remember, 1990 is also the time those technology company like Google, Netflix, and all those coming, Amazon as well. They use a lot of machine learning model to do the recommendation, etc. Yeah. And then at around 2010, there is another revolution in AI industry, which is mainly driven by deep learning technology. Okay, deep learning is actually a subset of machine learning technology. So So deep learning technology is the machine learning model which is using neural networks. So neural networks start from a very simple idea like it seems nowadays we have some idea of how the human brain works. Like maybe we can mimic how the human brain works. So that's the idea, but we all know we know very, very less about how our brain works. And so the neural network is trying to mimic how the human brain works, but it is very far away from actually doing what our brain is doing. But in not mentioning that, it is still a very powerful machine learning model. And it is especially powerful under unstructured data. Okay, so that is why deep learning is a kind of a revolutionary technology. So what is deep learning doing? So basically for deep learning model, they are using neural network model. So neural network model basically doing the layers, have different layering structure. So before we are using deep learning in the traditional machine learning model, like just now the DIPDs, Diagnose, normally your input is a tabular data. So you want to have everything be tabular, like so you have different features. So so in the past, okay, while we want to do some image task, we want to identify whether there is a car inside this image, okay? Normally, we will do a feature extraction first. So we will convert this image into a tabular data. We may come out some features, see like, is there any circle inside the image? Is there any rectangle? Yes, anything you can think about. Okay, so you will convert the image into a tabular data with all the features you think that will be helpful to tell whether there is a car inside the image. And then you feed that tabular data into traditional machine learning model, and then they will come out output tell you whether there is or not a car. Okay, so that's a traditional machine learning algorithm. But what deep learning doing is, deep learning will just directly feed the image, okay? Feed the image into the model. And they will let the neural network to extract features and do the classification altogether. And you may ask how to feed the image into the model, okay? And so image is stored in a computer or in an electrical device in your phone by pixels. So you may know like some high resolution photo, they have high resolution, they have many pixels, and low resolution, you have low pixels. So basically you can just divide the picture into small square, and each square is actually a number. Okay, so that's how the image is stored into a computer. So deep learning or neural network model, they will not try to extract some useful features from this image because they think human being may not know what are the relevant features to make classification. So they feed the whole picture into the neural network model. And in the first few layers, the neural network model will try to extract some useful features. Okay, then they pass to the last few layers, and the last few layers will do the classification. Then the output will be whether there is a car or not in the picture. Okay, so that's the difference between traditional machine learning model and deep learning model. Deep learning model basically combine the feature extraction and classification in one shot. So this is a famous cats and dog problem. So you need to train the model using a lot of cats and dog image. And of course, you need to label each image, tell the computer whether this image is a cat or a dog. Okay, then so each time you So you think about neural network like many layers. So you input many image. So the input here will be a cat image or a dog image. Then this image will go through each layer and they will come out a prediction. So let's see, the prediction is like 60% of chance this is a cat. Okay, but the actual label, maybe it is a cat. Okay, so there is a loss in deep learning term. You can think about it as an error. Okay, so so this image is 100% a cat, but your model set is only 60% of chance it is a cat. So the error is 0.4, okay, or 40%. Then you feedback this error to optimizer. Then the optimizer will update all the weights. Okay, so each neural network, inside each neural network, there are a lot of weights. So while we are training a neural network model, basically we are training the weights. Then the optimizer will update all the weights inside the neural network layer. Then this time you feed in the same image into neural network again. They may say 80% of chance this is a cat. So each time it will improve. Okay, until the model prediction and the true label are very close to each other. Okay, it means like when you feed in a cat image into the model, then high chance model will recognize it is a cat. Then you are okay with this model, then you can deploy it into a production environment and then to use this model to predict whether the image is a cat or dog. Okay, and so that's the deep learning technology, and deep learning technology is doing very well on the unstructured data. Basically, it's what we see image data or natural language, like the text, the text message. Okay, the text message, you type in the Twitter, Facebook, and all the social media. So deep learning model can deal with text message, image very well. So that's why deep learning create another revolution in the AI industry. Because before the deep learning model, before a deep learning era, most machine learning is focusing on tabular data. But tabular data is mainly actually useful in the business environment, right? Your company have a lot of tables, spreadsheet data, etc. But in our real life, actually, most of time we dealing with image, text message, etc. So now deep learning model can deal with image and text message very well. So we can clearly feel the revolution, the AI revolution in our daily life nowadays. Okay, so that's the deep learning technology. And then you may ask, you may ask like, why now, right? So this is a table Lincoln Laboratory developed to show data is very critical to AI breakthrough. They list some very famous AI breakthrough and also list the time the data being assembled and the time the algorithm being developed. So I'll let you focus on this one. So this is the convolutional neural network model. So this is a model we use to classify cats and dog image, doing all the face recognition, etc. So convolutional neural network first was like the first time it's being proposed is in 1989, and so that's like very 40 years ago. Okay, but after that, it's it's not being used in any like real life industry, I think. It just like limited in academic area. But until 2010, the ImageNet story. So some people from Stanford, they create this ImageNet competition. They assembled 1.5 million labeled image with 1,000 object. Like it includes many animals, vehicles, and etc. So I think they take 2 to 3 years to assemble those image. Then they open the image to everybody, to the public, so everybody can use those ImageNet image to train their model. Then after that, I think in around 2012, somebody using a convolutional neural network model, then they use this ImageNet data set to train the model. Then it created a big breakthrough on image classification. So previously, the accuracy probably around like 80% or 90-ish. But with the convolutional neural network, they significantly improve the image classification task by 7% or 8%. Yeah, I cannot remember the exact number, but that is really a big breakthrough. Okay, and so that is eventually result the deep learning breakthrough, okay, on all the computer vision task. Then people realize, so if we have enough data, if we have enough image, and use convolutional neural network, we can solve a lot of image problems. Okay, and so that is what we see, why it only happened in around like 2010, because that is the time we have all the image, although the algorithm being developed a very long time ago. And also another thing we need to mention is computing power. It takes a lot of computation to train a deep learning model. So 2010 is around the time we have a very good computing hardware, which makes it possible to train a model using 1.5 million images. Okay, and so the reason is at 2010, around that time, we have all these 3 things together, so that comes out the deep learning revolution. If you are interested, you can look at the other AI breakthrough, and you can see they actually do a calculation. It takes an average of 18 years to have an AI breakthrough since the time the algorithm being first proposed. But it only takes around 3 years after the data set being assembled. So from here we can see data is really very important for important AI breakthrough. So it is not say like algorithm not important. Algorithm, if you don't have algorithm, you cannot do anything. But there is still a very long way to let from the algorithm to the actual breakthrough. We need to have the data to train the model. Okay, so yeah, to let you have an idea about how the convolutional neural network model works and how we train a convolutional neural network, I will do a quick demo. Yeah. So here we use TensorFlow Keras. You can see actually you don't need many codes. So this basically this Jupyter notebook has all the model training and model evaluation and model prediction. So So because nowadays with all those like open source Python package, we can do things very easily. Okay, yeah, I will not go to each code line by line, just give you an idea. So we have a training data set. So in this data set, I have this 10 different kinds of food. And for each folder, you will see many food image. Okay, so in this chocolate mousse folder, I have different image of chocolate mousse. Okay, we download it online. So similarly for the other food as well. So what we can do is we can just load all the image, okay, from this folder. Okay, we'll load all the training image, testing image, and etc. We need to do some pre-processing on the image. Then we can build a convolutional neural network model. So this model has a few layers. The first layer is a VGG16 layer. So this is actually a pre-trained model. Okay, this model has been trained on that ImageNet dataset, 1.5 million images. Okay, so I can just add that pre-trained model as a layer. Okay, then after that, I add in some other layers as well. So this is my model. I will phrase most of weights, okay, or parameters inside the pre-trained model, because this model is trained on that 1.5 million image. So it's a very good model to do the image classification. So I don't want to retrain this model. So I phrase most of the model. Then I will only train some simple layers I added. So to train the model, you just need to compile it, and then you can train it. Okay, so I will not demo the training. It takes around 30 minutes. So each iteration is around 1 minute for me to train such a simple model. So after I train the model, so I can use the model. So I evaluate the model on all the testing image. It achieved around like 70% accuracy. Okay, and after I train the model, so I can use it to like make prediction on any image. So I give it a full image, and then it will be able to tell whether it is a falafel or a fried rice or some other thing. But the image needs to be in this 10 category. If it is not in any of them, then you probably will see some weird percentage. So this is a falafel image I downloaded from internet. So you can see the model basically will tell you like 99% of chance it is falafel, because it is a very typical falafel image. And it rules out the other category easily. But for some image, let's say this crab cake, okay? The model have some difficulty. Crab cake. It is eventually still identify it is a crab cake, like 54%, but it is a bit confused between crab cake and falafel. You can see 33% it thinks it may be a falafel, because these two are actually quite similar. Yeah, so basically that's how convolutional neural network model works nowadays. So now with all the open source Python package, you can basically do all those things like in such a simple notebook. Okay, so that's the demo. Let me get back to the slides. So yeah, I want to share a few case study, like because we all know like Google, Amazon, Netflix, those technology company, they have been using deep learning, machine learning in their daily work, doing all the recommendation, etc., and earn a lot of money. But what we want to see is the current deep learning technology can be applied to the small business as well, to the traditional industry as well. It is not only a high-tech company, they can utilize machine learning or deep learning technology. Okay, so here is an example. So we all know Domino Pizza, right? Domino Pizza actually use deep learning model to check their pizza. Okay, and so they take pictures of the pizza, and then they feed it into a deep learning algorithm to check whether the quality of the pizza is satisfiable or not. Okay, so instead of let a real human being to do the check, they just install a camera on top of the place where the pizza come up. Then they just take a picture. Then they automatically feed the picture into their system. Then the system will see whether it's okay or not. I think most of the time they will see quality is good, but in the case the pizza is in a bad quality, right? Maybe like something dropping and doesn't look good, and then they will be alert. Then they will exchange that one with a good quality pizza. But to build this model, you can use the pre-trained model. Like just now I used VGG16. There are many pre-trained model you can use, and on top of that, you fine-tuning the model using your pizza image. So Domino Pizza definitely has many image of pizza. So they can take a lot of pizza image and label them and use those images to fine-tuning the pre-trained model. And then they can use that to check pizza quality. Okay, so it's not only a high-tech company can use deep learning, the small business also can use. And here actually comes another advantage of deep learning model, the confidence model I showed you just now. So we have a pre-trained model on 1.5 million ImageNet images. Then we can just use that almost on all the image problem, whether you want to check pizza or you want to check other thing, like your company may have different product you want to check. You don't need to train a model on 1.5 million image. You can use that pre-trained model and you're fine-tuning it on your specific image. And then you can leverage that deep learning model to check like the quality of the product from your company, etc. So that is another reason why deep learning technology can be applied so easily in almost all the industry. It is very portable. Yeah, you don't need to, because it's not like every industry they can assemble 1.5 million image. You don't need to assemble 1.5 million image. You just need to assemble maybe a few hundred image, and you use that to fine-tuning a pre-trained image model. Then that will be good enough. Okay, another example is this is on smart farming. So we know like while people doing farming, they use a lot of pesticide chemicals, which brings environmental risk and hazard for human. Okay, so this company, they actually they use the computer vision technique. First, they sense where the crops are threatened by pests. Okay, they probably use some sensor, take pictures of all the crops. Then they feed those images into a model. That model can tell whether that crops maybe they see this part, the crops being affected by the pests. Okay, then they will just blast some chemicals on that part. Okay, and this part, the crops are okay, not affected by pests. Then they will leave them alone. They will not blast any chemicals in that area. Okay, so to do this, they need to have a model. Yeah, somewhere here, inside the helicopter. So each time they sense an image, then they send the image into the model. Model can tell whether this part is affected by crops or, affected by pests or not. If it is, then we blast, otherwise we don't. Yeah. So that's how we use this image computer vision techniques in farming. And the last one is smart hospital. I think many of you have hear about it. So the current deep learning model and the computer vision technique is mature, is very mature enough to read some medical scans, x-rays, and some other medical image, because medical image is actually very specific. Okay, so if I think there is a competition, I think a few years ago, like some hospital, they let their physician to technician to interpret the scan, then they let the AI model to interpret. AI model definitely run much faster, and in the end, they actually achieve higher accuracy than real technician. Okay, so this part, the technology is quite mature already, but I think the bottleneck is how can we let the AI model to assist technicians? Okay, because we cannot like really rely 100% on a machine to read those like important medical image, right? So I think the difficulty is how to let the technician and the AI model work together to achieve better efficiency, etc. Okay, so that's the 3 case study. I hope through this case study you get an idea the AI deep learning is not only for technology company. It is actually very useful to apply them in the real industry. Okay, so I will end the session by emphasize on the AI and data. Okay, so AI, normally you hear a lot of those terminology like AI, data science. It seems they are closely related to each other. Sometimes they're interchangeable. But general idea is AI is focusing on algorithm and method. So AI, machine learning, deep learning, we develop many algorithms, many models for you to solve your problem. Data science area, they're focusing on data. Okay, how to collect data, how to analyze data, how to extract important information from data. So as now you understand, the AI cannot perform without relevant data. To train the AI model, deep learning, machine learning model, you need a lot of data, and those data needs to be relevant, needs to be in good quality. So without data, AI algorithm can do nothing. But if you only have data, you don't have AI algorithm, it is also useless. Okay, so AI and data normally work together to solve the problems. And currently we have a very cutting edge machine learning, deep learning model ready. And so what we are lacking is the data from different industry. So I think nowadays AI is still mostly being applied in the technology industry because they collect a lot of data there. In the traditional industry, how to collect data, we need a lot of expert view, etc. Yeah, so that's what I think all of you can come in and help on this area. Okay, And we want to emphasize AI is critical, data is critical for AI. Besides just now the Lincoln Laboratory table, we can also learn this from history. In the past, there are 2 AI winters. And the first AI winter is because people realize the fact that we can solve a problem in theory doesn't mean we can solve a problem in practice. Okay, so now we have all these machine learning, deep learning models. So theoretically, we can solve many image problem, text analysis problem. But it doesn't mean we can solve it very well in practice, because for each industry, medical industry, finance industry, they all have their special problems. So we need the expert knowledge. Okay, we need the expert knowledge to combine with the AI algorithm, so we can get the relevant data to train the model and to solve the problem. So that's what we learned from the first AI winter. Then after that, people involve a lot of experts and develop the expert system. And then after a while, they realize it is very complex to do the hard-coded rules and etc. So that is where machine learning, deep learning take off. And I feel now we are kind of having some problem like what we have in the first AI winter. We have the more powerful tools, machine learning, deep learning algorithm, and the hardware, the computing power we have is much, we have more computing power than like a decade ago. Sorry, not a decade, 100 years ago. But the problem is still, we cannot just let the program do everything. We need the expert knowledge. So we need to collaborate the computer expert and the domain expert together to let the AI technology actually be utilized properly in the real industry. And a lot of people are worried, is there another AI winter? So personally, I don't think so, because many things are different this time. We have better hardware, we have big data, better algorithm, and a lot of investment, and government and big companies are all like supporting on this. So I don't think there is another AI winter, but I think we should focus on collaborate the computer expert with the industry domain expert. Okay, so here comes to the end. So currently we are actually still in the narrow AI stage. So AI can only solve a very narrow task. Like in the next stage, maybe we can develop some AI application to solve some general purpose application. In the even longer term, maybe we can develop some machine that can work and act like AI, like human, but we are still very, very far from that. Okay, and at the narrow AI stage, so we want to emphasize on the importance of data again. So recently, Andrew Ang, he's a very famous AI expert. He mentioned in many industries, their giant data sets simply don't exist. I think the focus has to shift from big data to good data. Okay, so in the last decade, the biggest shift in AI is a shift to deep learning. So he thinks it's quite possible in this decade, the biggest shift will be data-centric AI. Okay, so what he means is for each specific industry, like the manufacturer, healthcare, finance, while you are utilizing AI model, you may not have 1 million images or data. But if you can develop like 200 very good data, or he even mentioned 50, okay, very thoroughly engineering the data, then you use those data to train the model, and that may be good enough for you to get a very good AI model that can be very suitable for your company, etc. Yeah, so I think I think that's all for my talk today. Okay, so this is the so we are from the Advanced Computing for Executives. So this is a executive training function and the School of Computing in NUS. So if you are interested in the courses we are teaching, you can follow us. You can scan the QR code to follow us in Facebook and LinkedIn. So we will publish, we will post the course and the articles, the webinars and anything. So you can just look at there. Okay, then for this Smart Nation talk, we need your feedback by scanning this QR code as well. Okay, while you are doing this, let me look at the questions. So I probably don't have time to answer all the questions. There is a question from ZO. So while you are training deep learning model, right? Just now, let's say for that small model, it takes me half an hour to train it. But after you deploy the model, the prediction can be real time. Like just now, I used some image. Okay, I just run the image. Immediately, it tells me what food it is. So you can train the model at the back end. Until you're happy, then you deploy it into your like system. Okay, like that system may have some like a CCTV, the sensor to take image and etc. Then you feed the image directly, they can make prediction. Oh, the 1.5 million image, you just Google ImageNet. Okay, ImageNet, then you can see the project. Yeah, that is 1.5 million image. That's open source. Everybody can use it. Thoroughly engineered example means like, so let's say if you want to tell whether the pizza is good quality or bad quality, then you need to have good image, a very representative image of the pizza, which is good quality or bad quality. The model phrase and unphrase for fine tuning. So basically, you remember neural network model has many layers. So the pre-trained model may have like 30 layers, and each layer has many weights. And because those weights are pre-trained already, so you freeze them, then you will not change the weights inside those pre-trained model. Then you only add like 2 layers using your pizza image. Then you only change the weights in that, the additional 2 layers. Regarding Andrew, can we develop a dynamic data set instead of cleansing a fixed good data set? That means 10% of fixed data gets fresh and the model trained to see. Yeah. So yeah, of course, I think for any deep learning or machine learning application, you cannot just train it once, then deploy, then done. Normally, you will keep collecting image, and then you keep using the new image to train the model and to further improve the model. And actually, I think Andrew and their team actually developed a platform to collect image, to find the issue with the image, because sometimes you may label the image wrongly and etc. They actually spend a lot of time to try to collect image and label the image properly. Then they manage to improve their model performance a lot. Yeah, so yeah, that's good idea. Who is a go-to person for research collaboration? I think nowadays many companies should have the technology department, right? So so probably can talk with the people from the technology department. Otherwise, if your company don't have a technology department, then probably can reach out to university. I think the NUS definitely have some function to do some industry collaboration, etc. Yeah. Data will not be required to train AI. For now, I still think data is very critical for AI. Yeah, unless later we develop some new algorithm, then that. Oh yeah, actually nowadays there are some algorithm like because you have limited data, right, image, then they can self-generate some image based on, let's say you only have 200 image, then based on this 200 image, the model probably can generate another 2,000 image. Then you have a bigger data set to train the model, something like that. The demand in data science rose when machine learning is automated. I still think I think machine learning and deep learning are actually very useful even in the traditional industry. I think now what you may not need a lot of people who understand machine learning algorithm from computer science perspective, but I think you need a lot of domain experts who can work with the computer science people, the software engineering people, who can tell them how to formulate the problem, what kind of data they should collect, then how to use those data to train the model. I think we need a lot of people with domain knowledge and also can talk to data scientists.